Hmm. Hmm. Why is right offset to new node here? So we went from 10 to 11. Eleven was just added. Right. Ooh. Mhm. Uh, 7 to 6. let's say That is very, very, very close to 11. Well. And again, not using cubic, seriously. Yeah, okay. At least we don't crash anymore. So now it's going to jump to 12 again, which should give me a... Okay, that's nonsense. Continue. Yeah, an infinite loop. Reusing 12. Yep, it's reusing 12. Infinite loop. Yeah, well, I don't want to be bothered by this right now. Yeah, I would rather be able to just break out with it. Change this. Maybe put that here. So I want to be able to use break here. It's highly annoying. So let's just use this. Okay, I want to break here if we did not. Well, I want to break if we stepped over Q instead of into it. So what is Q? Q is use cubic. What if it is equal instead of less than or larger than? I might as well use cubic as well then, I suppose. That is not enough. I also do not want to not use cubic. Okay, I do not want to enter this if the new cubic does not contain the search for next local extreme. So that is again something with the cubic. Something with use cubic. So something like use cubic has next extreme type. Yeah. Next extreme type is an extreme type, and the use cubic is, I think this is a sample node. Yeah, must be an iterator to sample node. Which has a cubic, which is a cubic to next sample type. I think I'm not concerned with extreme order here, because the other, yeah, it should not be possible. I think that it contains the next extreme on the other side of the last found local extreme. So what about left max or right max? I think that's also a thing. As in, suppose it does not have an unfound maximum, but it has a maximum that we already found, in the case that we are looking for a maximum. And that's also not gonna happen. But what if it does? Might as well use it then. So what I was saying is I do not want to not use the cubic. If the cubic does not, that's a triple not. That's confusing. If the cubic does not have the sort for next extreme type. Trying to visualize this, otherwise I get completely confused. So if it does not have it, then I do not want to use it, so I want to use it. So it does not have it, I want to use it. But if it has a left max or right max and not a maximum bit, then I still want to use it. So I want to use it if it does not have a minimum bit or maximum bit, and if it does not have that, but it does have a left min bit or right min bit or left max bit or right max bit, then I still want to use it. So I only do not want to use it if it has a minimum bit or a maximum bit set. Yeah, so we have to detect if one of these two is set. And I guess I just don't care about that then. Which means this one. And true if the cubic fitted between this and the next sample has the given extreme in between the two samples. So I can pass the extreme type to this function, member function, and then if it returns true, then it does have that extreme. So it just calls one of these functions. So if it doesn't contain the next extreme type, then this expression must be false. No. What? Yeah, because then this is false, so then the whole thing is false. If it doesn't have it, then this is false. It's prerequisite that it has this unfound extreme, otherwise we don't even go into this. Okay, I think that should get rid of the infinite loop that I just had. I'm using a cubic here. That is must be a cubic. A cubic stands for an analyzed cubic, so that tells us not just the beginning and end point, but more where the extremes are and so on. So before we found 11, then 12, and then went into an infinite loop. Now we find 11, and then we just continue. Yay. So the reason is that previously it rejected the cubic between 10 and 11. But now it doesn't, because the cubic between 10 and 11 does not contain a maximum. So it's not rejecting it, it's using it. 10 and 11 does have a maximum in 12. So we jump directly to 12, which is immediately also the next local extreme, because the derivative is 0 at that point. And the left off is set correctly. So it jumps to 13. And then 15. Nobody knows where 14 is. So that took a while before we found this minimum here. Okay, and then it continues 19, and then we find this one, and then we're done. So that case now works. That's just one on something random. Might not always be the fastest, but I just wanted to not go into an infinite loop. Finish at some point. No, this one asserts, so. Let's begin with running it while it reproduces this one. Okay. The assert is it's kind of surprising that it fails. So it wants to it's detecting what the type of the cubic is, and it's either this or that. In fact, it is it's a wavy thing that as first has a maximum and then a minimum. So you would say it's this one. In other words, that is 1. Yep, but the assert fails. The assert fails probably because it ends here, and that is exactly horizontal. So instead of having this type, you really have one that is flat at the end. It should have been detecting that. That's the actual shape that we have. You have a maximum, and then it goes flat, and then it ends. So it should have been detecting this, I think. Let's go to the top of this file. Function, I mean. So we should have gotten this one. What's the name of this function? It takes forever. Oh. Yeah, what? Oh, frame 0. Guess this frame then. Initialize cubic, okay. Could do a rerun, I guess, at this point. And then find where it's calling initialize cubic. Yeah, nobody knows. I consider this just useless. Consider it useless, and I keep forgetting how to disable it. Disable pretty printer. Now we're talking. Though I still don't know what the type is. Sample node iterator. Point 3. And the last one was 7, I guess. 7. 0.7 was added here, and then we have a new cubic between 3 and 7. And then we're going to initialize it. Okay, step, finish, snore, step. Where the hell are we now? Step, step. Really step, bloody finally step, next, entering sample node initialize cubic. Let's see what the hell W is, 6.15, okay, so that's 0.3. Cubic initialize, yeah, that's just creating the cubic. Next node is next. Side, what is that? The current object, this was the last sample that was added, then the cubic is on the right of the last sample. We use a different color for that. Well, it's not on the right, it's on the left. Oh, it does get 1 there. So we had 0.3 and we are in 3 and we have 7 and we plotted the cubic and it's on the right, so it got this color. It's on the right of the new sample, that is 0.7. Now going to determine the type. Significant derivative. So, well, I guess that's going to be something larger than the actual derivative. Excusez-moi. 0.002. The actual derivative is then small, right? What? Oh, sorry, that's still 0.3. Yeah, totally significant. So the sign of the derivative is considered to be positive because we're going steep upwards here. And I think this sign should end up 0 because it's flat. That would be this one, so this one should be less. It's completely 0 even. Can you imagine? So we should get 0. No. Seems to work. Then how the hell do we end up in that maximum minimum thing? It's nonsense. Neither derivative is 0. Well, that should be false. So again, this one was 1 and this one is 0. So they are unequal. The easiest first. This must be maximum or a minimum, or very unlikely, one of the derivatives is 0. Well, this is the case. So I do it next, and we do get in 171. Neither derivative is 0, but one of them is, so they should be true. Oh, what the... Huh? Oh, no, sorry. Neither derivative is 0, and because one of them is, this is false. Yep, true. That's called likely, so this is not the case. So this is also not true. The right part of an extreme. So this is false. So we do next. 198. Yeah, that's the one that we want. Next, print the second derivative. It's a second derivative in this point, so that is a minimum because it is positive. And therefore, this is 1, right? Print it again. It's like a 4th time, yep. Next, type that, so it was assigned silently. Max left min, yeah, that's correct. That's what it is, and why is it why does it work now? Okay, this is highly annoying. Max left min. But it was the point where it went wrong. Continue. Again, breakpoint. Maybe this time we're lucky. Level 7. What? There is no cubic in level 7. There's nothing on the right of 7. Six. Oh, well, there is something. 6 is there. Oh. And that is what is going wrong. Okay, so this is the whatever. We had a breakpoint here. 23. I want to run this whole thing again and actually see the 6. So where is 6 then? 11. Okay, so all the thing from 5 till 12. 23. We test from 5 till 12. Just did a rerun now. Okay, I think we just got 6. 6 was added. 6 is added here. Initialize cubic or max left min. Also max left min, which is correct. Maximum is off the screen, but then we have here the left part of the minimum. Choosing maximum of left cubic because the right one does not exist. Yes, so we're going to jump there now. The trim jump. Next probe 7.9. Then we entered it again, so we just entered it with 0.7, I guess. Although not printed yet. Well, that is because I just did a restart. So now I can add my breakpoint back, and yep, I did forget the line number, despite my attempt. Thought it was 26, so let's try it. Algorithm 26. Not really. 23 then. Yeah, I'll already see it. So break 23 again, and then continue. That one worked. That is a left max left min. And now this one. We do a step. Zero, 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 zero. Okay, well that's oh. Oh, okay. Yeah, so we have a derivative of 0 in 7, as you can see. And we also had a derivative of 0 in 6. Now we are making a cubic between 6 and 7, having a derivative of 0 in both points. So I just get this horizontal line here. So that should be detected as being flat, completely flat all the way, which I have never encountered before and therefore I never took into account. There's a really small chance indeed that you have a zero derivative on both sides. It's even less likely than on one side. So I guess the initialize of that one is going wrong. Yeah, okay, let's try this. So the significant derivative, what is the significant derivative then? Oh, the significant derivative is 0 even. Okay, yeah, well, that's not less than then. 0 is not less than 0. Aha. Breakage. Yeah, I guess it's weird, but it's just only when it is exactly 0. This is a problem, I think, and this is exactly 0. And in that case it would be solved by making this less than or equal. In which case it's not really significant anymore. It's just not significant enough, but okay. Or I could add a separate test, of course. If it is equal to 0, then the sign is also 0. It is both 0. Now, I have to fix that. 163. Wait a minute, not that. Which file? Simple node 163. So let's see if we detect flat at all. If both are 0, then this is not true. If neither is 0, also not true. Both derivatives are 0. And then we look at, yeah, so flat should be detected. Not sure if then the rest works, but at least we got something. Yeah, how to solve this? It's not even true then. Significant derivative is currently 0 if the begin and end point have the same y value, the y coordinate. It's kind of nonsensical, of course, when it isn't flat. In this case, it really is flat, but significant is nah, not really. Instead of using the difference between the LW values here, I should use the height of the box that fits the thing. In other words, something a little bit more sophisticated than this. Same thing here. The absolute value is a positive value of a vertical scale estimate, so I might as well use that here then. And this is basically the W scale estimate. And then you have to fix this one. So this is correct unless the thing has an extreme in between those points. Man, how do you define that? So I'm a bit scared that maybe this is not holding in this case. If that's true, then we have a problem. So let's try if this is a problem in general. It is. Did analyze the cubic though. So on the current one, basically are always allowed to call it. Are we not? Right, the type is not set yet, but the cubic is initialized, and now I'm calling the DW scale estimate. Hmm. So it's not really the type. I'm calculating the type. So I should be using something else here, which is just some debug variable probably. Should do that. It's the same problem. I think it happens because I'm only defining the function between 0 and 8. And here the minima gets lower and lower and lower, and so it gets past 8, and then the thing is flat, and then we run in this problem, which I haven't fixed yet, therefore let's start at 4, and then hope that it... But on the other hand, I already ran maybe more often enough to know that it is not a problem here. To, well, whatever I did. But yeah, I do want to start it, maybe run it a little bit more often. Start at 4, more in the middle. Interesting crush in the middle. Sanity check even. Yeah, I don't have time for this right now. I'm just ignoring this. I guess I'll run into this again someday. Is something wrong with my voice? No, I was not looking at it yet because of... let me check my voice. Testing 1, 2. How do I check my voice? Nothing works anymore these days. Test. I'm not even hearing this, still not. It's a monitor. Test. Oh, that's okay. There is nothing wrong with my audio. Okay, yeah. So I need a better estimate of the derivative within a certain range of a cubic. And there is no AI that can help me with this. I got someone to use ChatGPT 01 preview, which would be Strawberry or the predecessor to Orion, for which they claim that it can get the gold medal of mathematical Olympiad and do PhD mathematical problems. And I just asked it a simple question and it got it wrong. It couldn't do an integral, simple integral, right? An integral that I saw without using pen or paper or tools or anything. Just look at the screen from my head, and I instantly saw that the integral is wrong. So much for AI. I'm getting so sick of this. I mean, not that AI doesn't work, because there is no AI. I know that. It's just an LLM, it's just guessing, it's not intelligent. But it pisses me off to no end that I keep making hype videos about it, claiming that we're close to AGI and that it can help with PhD research. No, it cannot. Nevertheless, I'll demonstrate this by let's ask Claude. I was about to renew my, this thing might still be better, but I don't know. Try it here. So the question is a simple question. I mean, this is a simple question, but okay, we're not talking to Orion yet or even one preview. And I'm willing to draw my credit card and get what is it? A new account for ChatGPT for that. But yeah, maybe it was so bad. I'm just not going to get off from my chair to get my credit card. I'll try it like this. So what is the maximum difference in y value? Well, y value is a bit vague. Let's just say the maximum difference man, how do you formulate that though? I'm thinking that perhaps any mathematical formula is probably better than. So yeah, what would be a good way to get some rough estimate of derivative? You could just take the derivative at the beginning and the end, and then take the maximum of that. But that also won't work if the derivative at the beginning and the end is 0, while it still is non-zero in the middle. So I think that the best thing you could do perhaps is just make an integral. What about just the square, integrate the square of the derivative? I mean, making it the square is a trick to make it positive, and then we integrate it, which is, take the average over the whole thing. And then afterwards you divide it by the interval, so you get rid of the average, and you take the square root, and then you have a sort of an average of the absolute value of the derivative, which would be a good thing. So instead of asking for the maximum difference, which would probably be require as much CPU, because you would still have to calculate the local extrema and then test if they are or are not in between this interval. And yeah, I don't know, it's just calculating as an integral is probably faster. Let's say I want to get an idea of the average steepness. No, well, not steepness, but average No, let's say times still absolute value of the first derivative of a cubic in a given interval. Let's say qx is the cubic, q is the derivative, x0 to x2 is the interval, let's calculate the integral over x1 to x2 of q1 squared divided by something such that we actually get something that makes sense. So for example, I think just divided by. I suppose divided by x2 minus x1. For example, let q of x be simply ax plus b. Then the first derivative equals a. And the integral I of x, let's say, is ax plus c, I guess. Yeah, nonsense. Let me just fill it in. So that is ax between x1. Let's do it in LaTeX notation. x2 is a times x2 minus x1. So dividing by seems to make sense. Okay, I'm missing a square here, obviously. I just integrated the derivative itself now. So the derivative squared is a squared, and then the integral of a squared. The integral is wait a minute, that's nonsense. Well, I integrate this with respect to x, so then you get a squared x. because this is just a constant. Between x1 and x2 is therefore then a squared times that. So dividing by that seems to make sense. Then the result would be a squared. Taking the square root of that then gives the average value of the derivative. So, what is the formula for an arbitrary Q? And then we were hanging some reason. I think it already answered, but this time you get a whole black dot, yeah? No, there we are. Yeah, Jay, I completely agree. Well, so far I didn't make any error. It's very slow now. Well, this is semi-intelligent that it inserted an absolute here. I left that away in my own text. Give the average value, I said. But I'm not going to say it realizes it, but it kind of, corrects my phrase by adding absolute, which is correct. Yep, and then I get this in an format that I cannot copy with my mouse. It's pretty annoying. Okay. Oh, wait, I'll do that here. Why? No. Seems X undefined. Is this the same thing? Nine a squared x2 to the power 5 divided by 5. 9a squared x2 to the power 5 divided by 5, and a minus sign in front of it. Well, it seems correct because I'm dividing by x1 minus x2 here, and this one is divided by x2 minus x1. So that's the minus sign then. And we have also the same thing with a minus sign in front of it and x1. It's a different sign. 3ab x1 to the power 4 with a minus sign again, and then we must have a plus 3ab x2 to the power 4. That's here. 2bc, 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 and c squared and third power divided by 15. Okay, would be that one combined with that one, I suppose. So it would be 20b squared and 15a squared x1 squared. 20b squared, okay. This is 30ac. Well, I guess it's okay. How do I get my 30? One mod. Oh, I'm looking at the wrong thing. This one. AC, yeah. AC, yep. Now, at least now you can manipulate it a little bit easier. I think that I should just do a substitution here with u or something. U equals x1 minus x2. So I'm rather writing, let's say, Yeah, so then the derivative with respect to x is the same as the derivative with respect to u, because du dx is 1. And we can do q substituted x is substitution q replace x with, well, x equals u plus x1. To display the thing. Makes sense. What? Yeah, okay. Nothing changed. Yeah, instead of defining it like that, I probably should just make it a symbol so we can actually see it. I mean, the fact that I do this replacement defines already this relationship. So if u equals x minus x1, then yeah, this is correct, of course. Let's do the derivative with respect to u. Now when I get the dq, let's call it just du, call this function of u. Might as well then do that. Yep, it's 0. No, it's not. Oh, Q, dude, QU. Yep. Across square, yeah, this is now a function of u, so I should replace u with 0, and here u with u, which doesn't do anything. And then the average is the integral squared minus the thing at 0 divided by u. Wait, that's not u. Okay, why am I integrating till u? No, it's not what you want. So what did I substitute? U equals x minus x1, right? So u runs from 0 till x minus x1. This is minus x1. No, forget the square. The integral of the square of the derivative function of u with respect to u. And then I want my average to be the integral where we substitute x2 minus x1 for u, I think. So we go integrate from 0 to that. Fill that in the integral, and then we subtract it, divide it by that, simplify it. I have no idea what the result will be. Something simpler, I hope. Nah, it got longer. Yeah, we're still dealing with the x1 and the x2, of course. So yeah, it's just let's try to do this with ChatGPT then again. Give me a new chat. What is the word? In of with respect to, or I'll use in. See what happens. Looks pretty much nonsense. The fuck? I need a button. It's as stupid as a, I would say pig, but a pig is a way more intelligent than this thing. A cockroach? Yeah, well, probably comes pretty close. I'll rewrite that. Let's begin easy, you know, so we can. Okay, I think this is what I meant. X1 equals A. Not really getting there. Well, how about just using X1? With what? Why is it the reference? Fuck, dude. No. to really type it almost yourself. Otherwise it can't copy it. It's the only thing that it's doing. Oh yeah, thank you for clarifying. My IQ is 10. I didn't get it the first time you told me to express q of x. Okay, the plus dot dot dot. This is unacceptable. So stupid. Yeah, thank you. Okay, now. Okay, so now if you integrate this between x1 and x2, you'll get fill in x2 instead of x, get something, and then subtract, fill in x1, which makes this 0, 0, 0, 0, 0, 0, except the c, so the c is subtracted. So you end up with just this, where x is replaced with x2, and then we make that say u, and then we have something that is simpler. So which is what I wanted. But I still have to type it over probably, because you can't copy it. So I'm gonna call that dq, I guess, for the first derivative of q in x1 squared times u plus dq in x1 times d, well, everything is in x1, so let's leave that out as well. ddq u squared plus 1/3 times dq dq u to the power 3 plus 1/3 dq times u to the power 3 plus 1/4 ddq times ddq times u to the power 4 plus 1 divided by 20. And suddenly I have the feeling I have to check constants as well, because you never know if this thing makes an error. In the end, you're never even winning any time with AI to check everything anyway. Maybe I should make myself a little bit better with Octave, so I can just do this quickly. I already did check this. Yeah, it's a quarter. Quarter divided by this 5 is 1/20th, and the quarter came from a half squared. Well, this thing squared, so you get a quarter times the derivative squared. Probably okay. I'm going to remove u, because you have to delete this by u. Huh? And then we can put the 1/3 u squared out of the parentheses. What did I say? U squared. Yeah, so the u squared is at the end, and the 1/3. And then we could put, I guess, 1/20th u to the power 3 outside. 1/20th, okay, I've got it. F4, yeah, do it. 1/20th, 5. not use the u to the power of 3. And it's gone, and this is u, and then u to the power of 3. I think I did that correctly. Yep. Yeah, well, maybe not. Maybe not. Let's keep this just 1/4 times that. Shoot to the power of 3. 1/20th. Power of 4. So we have a dq, which we have literally stored. And the ddq is, I think, also literally already stored. It's just a third coefficient, right, of the cubic. God, whether it start to do that correctly? Yeah, so that's a, well, almost the coefficient of the third power. The only problematic thing is the second derivative in x1. All in all, it's a reasonably small formula. I'm going to implement this. I have to make sure, however, that I did this right. Otherwise I implement something which I can't check, which is maybe not correct. Super annoying. Q is qx1 plus the derivative of q times something that we'll call u. Wait, is that u? Yeah, no. Huh? No, it is not u. My u is x2 minus x1. I'll just, yeah, I'll just use this, I guess. X minus x1. Plus 1 divided by 2 times the second derivative. Yeah, these are also in. I mean, I put an x1 here, I might as well put an x1 here. Second derivative, first derivative, second derivative in x1. I guess that already worked, but times x minus x1 squared plus 1/6 times third derivative in x1 times x minus x1 to the power 3. Right, so then we want to have the derivative. This is nonsense. So the derivative, I'll just work in x. No. So the derivative of q is then derivative of q with respect to x. Display that. QXO. Ding, ding. We don't have ABCD anymore. We just have QX, the derivative, second derivative, third derivative. Buzzing floating point, oh, 0.50. Oh, it's all the way down there. So, do we have an output here? The derivative of that is yeah, I was looking at what the but it just drops out against that. Maybe I should have simplified it. Simplify. Make it human readable. Yeah, so you just have I mean, just like this, you just have the first one, and then the taking derivative once times that divided by one faculty, and then taking derivative twice times that to the power 2 divided by the faculty of 2, and then 3, well, that to the power 3 divided by the, I say faculty, is that faculty? Factorial, I think, factorial of 3. And then here we have the exact same thing, but then we stop early and there's one d more everywhere, so it makes sense. Then the next step was square the thing and integrate it. So we have a dq squared integration over x I don't know. I want to integrate. I want to fill in 0 though. It should not really matter. Oh, what am I doing? This is just x2 minus x1 divided by x2 minus x1 is Simplify and display it. That isn't as simple as what I made. Where's the thing that I made? Oh, yeah. Yeah, it looks like the same though. This term here is this one. The derivative of q in x1. That's my abbreviation there, squared. And here we have u equals x2 minus x1. So we get this one twice here. The multiplication of the first derivative in x1 times the second derivative in x1, which is this. So the next one is then a u squared, which is exploding into all of these things. Because we have both dq triple q times x1 squared now. So there should also be a double dq double this is square here. There is a square here. That's not the same. I don't have a square here. If I want to get it in this form, I just have to get rid of x1 on x2. I don't really know how to do that. Not really. I think I shouldn't not use x2, but use u minus x1 instead of x2. No. The other way around. This must be x1, so it drops out. So it must be u minus x1, u plus x1. x1 plus u. So u is, no, what? Clearly, x2 minus x, u is x2 minus x1. So x2 is u plus x1. Huh? x2 is u plus x1. So we don't have this. x2 is u plus x1. So I'm just going to use that. u plus x1 minus x1 is u. Okay, so let's fix this. The integral from x1 to x2 of the first derivative, actually, squared of x divided by blah, 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 is given by where u is x2 minus x1. There we are. Now that looks like this. So now you have the dq, no, forget about the x1, squared dq ddq times u plus 1/3 times dq dq times u squared plus the ddq squared, so it was wrong, times u squared divided by 3 plus the a quarter, just started the back, u to the power 4, yeah, and this one is ddq times triple, yeah, it's all correct except that I need a square here. Apparently. So it's good that I did check it. And let's see if we can find that back here. So that is the u squared thing, it's this one. Squared. No, it's the third power because it's already divided by one of them. Yeah, just that square. I've got this square here. Good. So then let's use this. Yeah. Poop poop. Should just copy it over into that other window so I don't trust myself anymore. At least this is canonical, you know, Octave does not make errors. And then we want to edit not this, but I was editing in the other window. Totally the wrong file, I guess. Initialize node. I think maybe initialize cubic. I don't know anymore. Story. Was that sample node or what was it? Algorithm. So I probably need sample node to edit this one. Yep. So that calls DL DW scale estimate. which calls LW scale estimate, which we're now going to improve. And well, as follows. Formula. dq in x1 is that's the first derivative and the current node. The current node is current object. So that would be the DL, the W value. Check if that compiles. Yep. And then the second derivative in x1 we have to get that from the cubic because I don't have that stored here. So that cubic is having second derivative function. We can just recall. So that is the second derivative in x1, which is w here. Then this would be the third derivative. So that is cubic. Well, I don't have a third derivative, but we can just get the third argument. And then I have to do something with that in order to get the derivative. I suppose multiply by 6. Let me see. So I have a times x to the power 3, and then the first derivative is turning that term into 2 times a times x squared. No, it doesn't. 3 times a times x squared. And then the second derivative is 6ax, and the third derivative is 6a. And this is then, a is the coefficient. So we do 6 times that, and then we have the third derivative. And then I have, let's see, get every pair once, and or squared. It feels like a something squared. not quite, not quite. No, okay, let's not try to simplify it further. Anyway, my u equals x2 minus x1, which would be scale estimate. I'll just use this. So then the average absolute derivative is the standard square root of something, and that's what we return. Yep. I think this is still easier to use. Let's use that one. Should have done it the other way around. I don't know why I'm doing it like this. Okay, now we can repeat it anyway, I think. Just start here. Plus, obviously, this something times u. So plus 1/3, well, 1/3 times that. Yeah, parentheses around it. times u. Yep. Standard utils. I wish. Util square of dq that is your reduce dq. Forget the x. Plus something times u. Plus dq times ddq plus something times u. Where the something is something divided by 3.0 plus something times u. And then this is going to be 0.25 times that. Plus that times u divided by 20 . And this here is this part. So dq times dq plus utils square of ddq. Okay, no mistakes. Yeah, you could wonder if it is worth it. Loosely defined estimates, wave, and wavy. And then we have to calculate all these multiplications and squares, well, which is also a multiplication. And a square root. But okay. Okay. R. Absolutely no idea where I was. h. Oh, that's interesting. Oh, well, that one, yeah. Probably need to cache it because of the calculation and stuff. Or not. Oh, it's called there as well, yeah. It's called in two places. Oh boy. Yeah, probably should cache it. Or not. Damn it. Okay, this never happens. Both rows are 0. So we might as well assume that the previous place is the only one which gets called from initialize cubic, yeah, which is only called once. There's no need to cache it. Caching would mean that I have to increase size of the sample node struct, so that would be don't want to increase that. And still we are going to crash because in the case that we had, the thing was actually flat. But to get around that, I can now just change this into less than or equal, I think. Flat, flat, flat. Let's use some more. Hopefully that was the one. That looks very flat. I'm not sure this. It still crash. Oh yeah, I think that was the one. But why are we still crashing? Oh, ouch. What nonsense is this? Let's try that again. This cubic is not flat. Surely this is not a negative number. I mean, it's supposed to be the integral of a square. Cannot be negative. No way. Stupid GDB. What? It should be impossible. I just printed it. I have no fucking clue why it keeps repeating stuff. Let's make the copy of this. Is that really necessary? Oh, great. That's just when I wanted to ask the actual question. And this only happens because it keeps repeating itself. Square root of the square root of the square of the first derivative plus the first derivative times the second derivative. Times u. Yeah. Plus 1/3 first derivative times the third derivative. 1/3 first derivative, third derivative. Plus 1/3. What? What the? Maybe it's a formatting thing, but it's just what it started on a new line. Well, let's, I don't know, stop the square root and start over. Okay, ignoring that's the problem. 1/3 second derivative squared. Also times u squared plus 1/4 times the second derivative times the third derivative times u to the power 3, and the last one is 1/20. Ah, there's a square missing here. Apparently. What's this doing here? On 20th triple thing squared. Did I miss that in my own code or what? Seems I did. Quit, yes. Try this again. Yeah, got past that point. Okay, and not this point. But this is something totally different. Aha! Flat got detected. And apparently min left max, so what is it? The word exactly is it checking this? The type must match between what? Previous type and the current type. The current type is the type of 7. Okay. So 7 is flat, and then the thing before 7, that must be the thing between 7 and 8, or what? Yeah, I think so. I don't see a cubic being drawn there. It could be something that is like that, but okay. Left, min left max, yeah, that's true. So first you have a minimum, and then we have the left side of a maximum. And actually that should be equal. And I think the reason that it's not equal is because flat is interpreted as the at the bottom, so more like the left part of a minimum. But yeah, might as well the left part of a maximum, of course. So this should have been correct. Ugh. So one of them is flat, then this would fail if the other one has an end that is flat high. But in fact that is not a problem. It's doing a lot of crazy things. It's not crashing, but come on. What the hell? No, it finished. Oh. A short sample here, then 3 here. This minimum isn't even detected. Doesn't make any sense. Let's have another look at that. That must be detected, otherwise we would not jump here. I think the green thing is overridden. Yeah, it is detected. It says 2 here, so... Oh, that's weird in itself. Okay, well, yeah. What an edge case. I mean, a cubic that defines the local extreme is not allowed to contain 2 extremes. So this one seems to contain both a maximum and a minimum, but on the other hand, it is the cubic between 0 and 2 that defines this one. And this one is defined by 2. So that would be one that contains 2 of them. Unless 0 is a little bit on the right of this maximum, then it does not contain the maximum. Or this one is just not containing the actual minimum here. But it becomes so close that you would say that at the very least it is flat. And this side, so this would be the right side of a maximum, this is the left side of a minimum. Is that allowed? Guess so. But what a mess here, man. Start over. What the hell is this doing? 0. We go down, then we go up, find the maximum. Then we jump here. So far so good. We jump back, 4, back again, 5. This finds a cubic between 0 and 5. What is the type of 0, 5? Up. No, I don't think so. 5. No. No. Yeah, well actually 5 is min, which therefore means 5 is here. So 5 is a little bit on the left. So that 5, 3, cubic between 5 and 3 contains this minimum. So the cubic between 0 and 2 does not contain a minimum, therefore this is allowed. Anyway, we just had 5 here. So now we go way too far, all the way to 6. And since the function is not defined here, it's just 0, which means that it is it has a derivative of 0. So the type of this thing was max and then flat here, as in right min. And then I guess we're looking for a maximum, so we jump here. And then we should be jumping to this maximum, I guess. Which is still past that point. But now we find it. So 6, 7 and 8 are basically just thrown away things. We're backtracking. And then 9, 10, still not there. Whoa. 11 finally finds it. And then we still have to go this way. So we jump here. With 12, right? 12, yes. And then we find this one almost. 13, okay, 14 finds it. And this is higher than that one, so now we go to the left of point 1. And you're just going downhill, 15, 16. Should not return here. Huh? Well, that's kind of strange as well. I thought 16 was on this side, and now we jump all the way back till here. Okay. Zooming into wherever this minimum is, 19, 20, 21, and we found it. And then we should jump back here. Yeah. Okay, so actually it's doing a sensible thing. Okay, that bug was then fixed. Let's start, let's test it. I mean, I'm starting at 5.5, which does make us go over the border of 8, where the thing is flat quite often, and then, well, I just don't want to crash. Oh, wait. And there we go again. Though maybe not related. Second quotation fault, not an assert. Assert in a local, what? It's a stack overflow or something. Nope, not a stack overflow. Local extreme is undefined. That would explain it. This is nonsense. So the neighbor of the neighbor is nonsense. The neighbor of the neighbor was set to... What is neighbor? Looks a bit undefined. Totally undefined. Pretty likely neighbor is chain end. Yep. Can't do that in that case. Let's have a look at that file. Well, we're expecting to find it in the first place, so I could add an assert here. Check set neighbor is not end. It should not be end because sole minimum was set. Hmm. Oops. Close call. Almost at the beginning of the scroll back. I don't really get it though. So a rerun is not using the same seed. Yeah, guess it isn't. Strange things are happening. Oh, it's again a sec fault. I never saved this file, seriously. Already true. Okay. This is going on. I don't think it found this minimum yet, so the only minimum that it could have seen is this one, which is definitely not a neighbor, because we skipped two extremes. But how would I know that? I mean, if I just find first this one and that one, and the next one that I find is this one, then they are neighbors. It will be oblivious of the fact that we just skipped a minimum and a maximum. It should be, at least. Well, oblivious. There's the 0.5 here, which tells us it could have known. But yeah, I don't know. What is going on? Yeah, exactly. Exactly that. Maybe I should go eat or something. I'll fix the fix the whole series of bugs already. I'll keep this for another time. I think I'm gonna quit. Let's just let me play a game of chess first. I have to decide if I go eat something or not. I probably should. But yeah, my rating is so low again. It's unbelievable. Prove it. Shall I take the second pawn as well? Oh my god. I'm gonna do it. I'm just going to do it. And then we give check. So let's spin the thing. We attack this pawn. And then I take back with the bishop. And I have to move my queen. And I can go here. Maybe I'll take my knight then. Try it. Just gonna go back. I think it's gonna go here, the bishop, to stop me from castling. Then I can develop again with the tempo on the bishop. Although, then the bishop comes here. It gets really annoying then. And then the pawn here. Much will resign by then. I think white is winning here, despite my two pawns. They have to play the bishop here. Otherwise I castle and then I should be okay. No? Right? Shouldn't I? He is not doing it. Probably not the best move. Because I could take the knight and then still play the bishop. But okay, I'll take back like this, and then I'm threat to exchange the queen, so maybe... Oh, he's not doing that. Not doing that either. It's doing nothing. I'll probably still lose, but okay. Suppose I castle, take, I have to take with a pawn, then comes a check. Go there. Check on the pawn again. Yeah, it doesn't feel good at all. Let's not castle. Let's begin with giving a pawn back. Just you know, nonsense. What did I win with that? Nothing. I'm sure going to castle now. Oh, or not. Okay, let's not castle. I'm not even pawns up anymore. Can you imagine? Maybe do this and just stay in the middle. One, two, three. Take, 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 and then go away. That should work. I just lose another pawn. That's all. Uh-oh. Okay, no, I'm dead. Dead. The bishop goes away and then I have to go here or something. And I lose my queen. Yeah, okay. Let him do it. So bishop goes away. I go there because the bishop, yeah. I go here and then takes my rook and then takes the queen. I'll resign now because oh. Okay, let's think about food. I'm going to stop the stream.